Alright, so I'm going to make a really quick video on Newton's third law. Today in class we talked about Newton's second law, and I left you with this sort of conundrum here, right? You've got this guy's in a car, or a truck I guess, and this is a piece of metal, and this is a piece of magnetic metal, therefore it's attracted to magnets. And then you have here a very, very strong magnet. Incredibly strong. The rest of it's made out of some non-metallic metal. Non-magnetic metal. And so this magnet's going to pull on this. And the idea is that, if you have this super powerful magnet, it's going to pull the truck forward, and then it can go without any gas, right? You don't need any gas at that point. You need a brake to be able to stop it, but otherwise you don't really need one. Now this probably bothers most of you. But let's see why it doesn't work. And to do that, we're going to have to look at Newton's third law. Now here's Newton's third law. You've probably heard it before. For every action, there's an equal and opposite reaction. Or sometimes you might hear, for every force, there's an equal and opposite force, reaction force. So you can write that down if you'd like. Maybe pause and do that. But every action, there's an equal and opposite reaction. What that means on the very basic level is that forces naturally... It stopped recording. So what I was saying is what Newton's third law means on the very basic level is that forces come in pairs. So look at these two skateboarders here. This is a nice picture, right? So they are pushing. Let's say they push off on each other. Well, let's say this guy doesn't push at all. Only this guy pushes. So this guy's going to push the guy that way. Well, what do you think is going to happen? Okay, first of all, this guy's going to move away. But what happens to the black skateboarder? He's also going to push backwards, right? You can imagine this. If you don't believe it, you can try it out. Get two, rolling chairs or something. Push on each other. If this guy pushes him, notice that he's the only one pushing. If he pushes him, he will also move backwards. This is because of Newton's third law. Actions or forces come in pairs. If you push on him, then he pushes back on you. Even though he's not actually pushing, you receive a force back. And if you think about it, this is what allows you to do push-ups, right? If you're going to do a push-up, okay, let's say, just for my purposes, I don't want to make this very long. Okay, this guy's going to do a push-up. Well, you know that he's going to push down, yet he moves up. Because, again, if he pushes on the ground will push up on him, and he'll be able to do his push-ups. So Newton's third law explains how that happens. Newton's third law says every action is equal and opposite reaction. Well, let's go back here. Again, it stopped recording, so hopefully you got that part about Newton's third law, and the push-ups, pushing up and down. I don't know if it was on there or not. I think it was, though. But when we go back to this, you see here that there's definitely going to be a force, right? There's going to be a force of, let's say this is a magnetic force. So let's say, okay, obviously this piece of metal is going to be attracted to this magnet. So there's going to be some huge force this way, right? Because it's a very strong magnet. So some huge force. I wish I could make it bigger, but that's as big as I make it for now. But what does Newton's third law say? Well, if there's a force on this, so if it pulls it that way, then there must be an equal and opposite force in the other direction. See? So it is true that the magnet pulls this forward, but what is also true is that because the magnet pulls on that, this actually pulls back on the magnet as well. And look what you have. You have two forces in opposite directions. We talked about this on our force diagram. This is a force diagram. Then these two here just cancel out, and the net force is 0. So while this is a cool idea, it just doesn't work because the net force is 0. And because the net force is 0, then you're not going to have any motion. Newton's second law and first law say that if the net force is 0, then it just doesn't have any acceleration. Right. So as I said there's going to be a short video. Make sure you tell people, your friends, text them right now and tell them they need to. It stopped again. But anyways, make sure you text your friends and they know they need to watch this video. There's probably going to be a really short, maybe 2 or 3 question quiz tomorrow. That'll be really easy if you watch the video. But if you don't watch the video, it might not be. So tell your friends that they need to watch the video before they get to class tomorrow. All right. See you tomorrow.